All right, take the door. All right, so we're working on today. We're working on solving more linear equations. Okay, and our little scenario today deals with two tile companies: Cover and Surrounded, and Tile and Beyond. So the focus for this is going to be what are the strategies for finding a solution that is common in two variable linear equations. So we're using two, not one. So for Cover and Surrounded, they charge $1,000 to design your tile and deliver it, and they charge $25 per tile after 12 tiles. Excuse me. So you can see their equation is right down here. And then Tile and Beyond is $740 for the design and delivery, which is quite a bit significantly less, right? But they charge $32 per tile after 10. And so you can see here, so obviously the first set of tiles are free. They're kind of covered in this cost here. That's why you see the minus 10, the minus 12. So within here, it says you can use subscripts to show the different uses for a variable. Like C and then subset C means that the cost is the cover and surround it. The other one is the tile and beyond. Okay, sometimes you see them use 1 and 2. Like remember when we used to find slope, remember when we used this equation? Right? That's the superscripts or subset. Okay? So same idea. So here's what I want you guys to try to do is it says tell what each piece of the two equations means below in the context of the situation. So what does the 1,000 mean? What does the 25 mean? The n minus 12. What do all these pieces mean in terms of the situation of the story? So we're gonna pause this video. We're gonna give you guys a couple minutes to try to talk about it and see if you can dissect it, and then we'll come together and see what you got. All right, go. All right, so for cover and surround it, the $1,000 represents what? Yeah, that's your design and your delivery fee, right? Yeah, hey, your 25 represents your your cost per tile. And then this represents the n minus 12 is your number of tiles, right? And this kind of works together with the whole thing because if I plug in a 0 here, we get negative 12, right? That doesn't make any sense. But if I plug in a 12 here, I get 12 minus 12 is 0. So there's no cost for the 12 tiles. But once I go past 12, I start getting positive numbers, right? And that's where that cost per tile will come in once that number's passed. So basically, they're giving you your first 12 tiles for free. That's why they subtracted the 12 from the n. So it's not going to, those first 12 tiles aren't going to factor into your costs. And obviously, we're tiling something that's going to require a lot more than 12 tiles. So, they've given you a price off on the tile itself. So same thing down below. 740 represents your design and delivery. $32 is your that's your cost per tile. And then this represents your number of tiles. And again, the same thing here. Once I go past 10, I start putting positive numbers in here, right? Because 11 minus 10 is 1, 12 minus 10 is 2, and so on and so forth. So after 10 tiles, that starts to become a positive number. All right, so in question A, then it asks us, without using a table or a graph, find the number of tiles for which the two costs are equal. So when I have two equations, and I want to find out where they meet at the exact same point, where in this whole equation do they meet at the same point, what do you think I could do? I want to find where the two costs are equal. This is being the key word. Equal. When I have two equations, when I want to find out that they're equal, I'm going to set them equal to each other. Okay, so I'm going to take 1,000. And I'm going to set it equal to, so I'm basically taking the cover and surrounded equation and setting it equal to the tile and beyond equation. So basically this is I got variables on both sides, right? Which we've solved these type of equations before. So now it's just using our skills, and when we find n, the number that same number of tiles, that's when those two companies' costs will be equal. Because one line's going one way, one line's going another way, and eventually they're going to meet at the same price. Okay? So if I take this 25 and distribute it, I know that 25 times n is 25n, right? What's 25 times 12? Is it 300? Okay, and then I got the other side. I'm going to distribute this side. So I'm going to have 32n when I take 32 times n. And 32 times 10 is 320. 320. Now it's Monday. No one wants to talk. All right, well, on both sides of the equation, I have like terms. I can take 1,000 and subtract 300 from it, which is what? 700. So on the left side, I'm going to have 25n plus 700. And then I got like terms over here. I got a 740, and I'm going to subtract 320 from that. So what is that? 420? Okay, now I got it down to a more manageable equation, right? The trick I always told you was move the variable with a smaller number in front, right? Which one is that? 25n. So we're going to subtract 25n to both sides. Because remember, what you have to do to the left side, you have to do the right side. I think we're going to run out of room here, so we're going to make this just a little bit bigger. So we got more page here. There we go. All right, so this cancels out to 0. And I'm left with 700 on the left side. And 32 minus 25 is what, everybody? 7. Plus 420. So for me to get the 7n by itself, what do I got to do? I got to move the 420 over to the other side. And how am I going to do that, Nolan? Right, I got to subtract it. It's opposite. So when I subtract 420 over, I got 0 on the right side, so I'm just left with 7n. And on the left side, I got 280. So when I divide both sides by 7, n, which represents my number of tiles, is going to be what? 40. So if you order 40 tiles from both companies, the costs will be the same. Okay? Before the 40, if I'm not mistaken, I believe it's going to be the tile and beyond will be cheaper. And then after 40, this one becomes cheaper. You'll see if we graphed it. Okay? So 40 tiles, they're equal because we set both equations equal. So that's when they share the same cost at that number. Okay? Setting the two equations equal. Okay, so in part B, it says how can you check your solution, or that your solution is correct? Yeah, if I plug 40 in for n for both equations, I should come up with the same number, right? Or if I set them equal to each other like I did before. So if I go over here, I did all this work to break down these equations. I can use this part right here. That's after I distributed and combined like terms. 25n plus 700 equals 32n plus 420. So if I go to the other side and do that, oops, plus, it was 420, right? And I plug 40 into n for both of those. My left side should equal my right side if we did it correctly. So 25 times 40 plus 700 and 32 times 40 plus 420. Well, 25 and 40 is what? Is that 1,000? Is it 1,000? So you get 1,000 plus 700, which is 1,700, right? And then 32 times 40 is what? 1,200. 1,280. So 1,280 plus 420 is, hopefully it's 1,700. Is it? Yes? All right, so it checks because the left side equals the right side. So that's how we can tell when we check it is we plug it back into our equation. And why not just plug it into the part that we already distributed and combined like terms instead of plugging it into the very beginning where you got to do all that extra work, right? Work smarter, not harder. Okay, so for the next part, you got two problems here. And I want you to see when you set those two equal to each other. Now there's a typo here in number 2. You see this 1 minus x and then there's a 0? That's actually supposed to be a closed parenthesis. Okay? So what you're going to do is you're going to solve those two equations with variables on both sides to see where it's equal to and check it. So I'm going to give you guys about 10 minutes to do that with your groups. So we're going to pause the video and let you guys do numbers 1 and 2 in part B. Is this recording and I just can't see it because I forgot to unfreeze my screen? Yep, okay. So, let's see how you did. Well, number 1, if you got 2.2, negative 2.2, how many people got that? That was correct. So you're going to start by distributing, right? So I got 3x equals 5 plus 6 plus 8x. And when I combine my like terms, now I always said to move the smaller number, but since there's an x over here, it's easier if you just take this and slide it over, the 8x. So subtract 8x, and I get negative 5x equals 11. And when you divide by negative 5, x equals negative 11 fifths, or negative 2.2. And when I take that and plug it up into the original equation, 3 times negative 2.2 okay, this becomes negative 6.6. And you can literally just plug this whole thing into your calculator on the right side, and you get negative 6.6, which means that checks. Which means this answer right here is correct. Okay? 4 legs, please. Now, number 2, we got a little bit more going on, right? We got parentheses on both sides, which means we need to distribute. So 7 plus, and I'm going to take 3 into both of these, so I get 3 minus 3x for the left side, and then I got 5. And then remember, I'm distributing a negative 2. So I get minus 6 plus 8x. Was that the one mistake everybody was making? Did 2 as opposed to negative 2? So combine your like terms on both sides. The left side is 4 minus 3x, and then the right side it's negative 1 plus 8x. Oh, 7 plus 3 is 10. You're right. 7 plus 3 is 10. At least you're paying attention. You're not talking to each other, but you're paying attention, so okay. All right, so let's add 3x to both sides. And I get 10 equals negative 1 plus 11x. So let's carry this over to this side because we're running out of room over here. So I'm going to move the negative 1 over by doing what? Adding it. Got to do the opposite. So that goes away. I'm left with 11 equals 11x. Well, this is going to turn out nice, right? If I divide both sides by 11, x equals what? 1. So if I take 1 and plug it in here to check it, and then 4 times, so this is basically just going to be 4. Well, this is simple, right? Because this becomes 0, and 3 times 0 is 0. And then this becomes negative 1. So I get 7 equals 5. And negative 2 times negative 1 is 2. So I end up with 7 equals 7. Check. So how many people got 1? Very good. So that checks. All right, so now for those same pairs of equations, we're going to graph it. That's what C is. So if you go down below here, so it says for C, find the values of x that make y1 equal to y2 without using a graph or table. State whether they're, now, these 3 solutions, okay? Huh? But we already set these equal. When you have a finite number of solutions, okay, that usually means it's one solution. Okay? So you end up with an answer like x equals 7. Okay? When you do an infinite number of solutions, right, that's a scenario where you kind of get, like remember we did the solving equations that one sheet the other day where you end up with like 6 equals 6? Their variables kind of cancel out because the 2 equations were the same exact on each side. That's how you get the infinite number of solutions. Okay, so when you get the left side equaling the right side, basically. And then for no solutions, is usually when you plug it in and it doesn't work, right? Where the left side does not equal the right side. Like remember that one above it when we did that one worksheet with the 8 questions on it, and you got like negative 2 equals 6 or something like that, and it didn't work. So those are the 3 possibilities when graphing. Meaning the lines either touch, that's one solution. They don't touch ever. Usually those are parallel lines, right? That's no solution. Or if they're the same line, they're basically together, which means every point on the one line makes the other line true, which is infinite. So if we take these 2 equations, which we've already solved for, right? Wasn't that, didn't we solve for that on the front page? Nope. All right, let's set, we'll do it the way they're asking. So let's set these equal to each other. So 3, set these 2 equal to each other. So distribute the 3, so 6x minus 15 on the left, and 6x minus 2 plus x on the right, which gives me 7x minus 2 on the right. Okay? So I'm going to move the 6x since it's smaller. You with me? Yes? Okay. And that's just going to leave us x, right? 7x minus 6x is 1x, right? And then if I add 2 to negative 15, if I add 2 to negative 15, what do I get? I'm going closer to 0. Negative 13. So basically that means is negative 13 would be the point, the x value, where both solutions are true. So since I got x equals negative 13, There should hopefully be a finite number of solutions. So we're going to graph these two equations. Now, we kind of broke them down already to here, right? This was y1, right? So y1 equals 6x minus 15. And y2, once we distributed and stuff, was 7x minus 2. So they give us a crummy little grid down here to graph. There's really no intercepts here, so let's see if we can figure something out. Let's get out of this. All right. They don't give us the best of these graph situations. So I'm going to kind of make my own x-axis here and y-axis on this graph, and we can use the grid points to graph as best we can. So there's one line. That's our x-axis. And there's our y. Which means that there's your 0. That's -1, -2. Right, then you got 1, 2, 3, 4, 5, right? Okay. Well, the 7x minus 2 is probably going to be the easier one of the two to graph, because -15 is like way down here, right? So, -2 is the y-intercept, right? Right? Because y2 is 7x minus 2. And minus 2 is the b, right? The y-intercept. So if I use the slope to graph it, it's 7. What do we count as 7 rise over run? We go what? Right, which is what? What direction we go 7? Up or right? Up 7, right 1. So 1, 2, 3, 4, 5, 6, 7. Right 1 puts us right there. And I'm going to use my straight line tool because you guys have already known that I can't draw a straight line. I'll make it a different color so it stands out. And as best I can, that's pretty terrible. That's not bad. So there's the one line. Pretty steep, right? 7/1, that's a big slope. That's a pretty steep slope, right? So now we got to try to figure out how to graph. We're going to graph the other one. We really can't really fit it on here because this is 6x minus 15. So just think about it real quick. Just try to visualize this. At 0, -15, we're way down here, right? So if I go up 6 and over 1, let's say that puts me right here. What's that point? If I go up 6 from -15. -9, right? So this point here would be 1, -9. That still doesn't fit on that graph, right? Right? So let's go up another 6 from -9. Where does that put us now? -3. All right, well, we're getting closer because that would be 2, -3. Let's go up 6 more. +3, right? And 3 over. Okay? And this line's going to kind of go like way down here, right? So you're almost not going to see this thing intersect. And I'm going to tell you why in just a minute. So to make my line, I'm just going to go up 6 more. 1, 2, 3, 4, 5, 6. So somewhere about right there makes my other dot. Okay? So we can draw our other line. I'll make this one a different color too, just so we can see it. So if I stretch this, on our visual right now, we're seeing that it doesn't intersect. But if you look at the shape of those two lines, you know it's eventually going to intersect, right? You with me? It does intersect, right? So where are we going to find out that it intersects at? Jamie says at negative 13. Well, again, we set these both equal to each other, right? We got x equals negative 13. So if I plug negative 13 into here and here, we should end up with the same y's. Where's my calculator as well? Okay, so my graphing calculator says there's 6x minus 15 and 7x minus 2. Nope, that's not right. Let's go back up and over. Minus 2. There we go. All right, so you can see my two graphs right there, right? Sort of. You can't really see they intersect. Well, when we solved them, we got the x-coordinate at negative 13, which means on my x-axis, negative 13, way over here, is the x value where they intersect. We got to figure out the y value. So if I go to my table and scroll up to negative 13, I should see the y value where they're the same. Negative 93. So that's where those 2 points intersect, which is way off of our calculator window, right? So you see that? You see the two y values? Yes? So basically when I plug negative 13 into both these equations, this one and this one, I get negative 93. So negative 13 and negative 93 is the point, one point where these two lines meet. So it's like way over here and then way down. Okay? So these lines intersect at one point, which means they have a finite number of solutions. One solution. And it's this. The point where they share is the one where they meet. Okay? So let's do the second one. Number 2. Now, number 2, if you notice, it's not quite, it's a little different, right? So if I distribute y1, I get 6x minus 15. And if I distribute this guy, I get 6x minus 2 plus 7, which is 6x minus 5. So I got my two equations here. Okay? So I can set them equal to each other. Something's going to happen here, isn't it? Who sees it? I'm going to subtract 6x, right? What happens when I subtract 6x? Those guys cancel out, leave me this. Negative 15 equals negative 5. Plus 5, you're right, it's plus 5. So negative 15 equals 5, right? Is that a true statement? No. What happened when that scenario has come up in the past? What did we say the answer was? No, not infinite. No solution, because this can't happen, right? So this is a no solution, right? Which I think in the directions on that was the third option, right? Why is it no solution? Well, if I graph these two lines, gosh, and they're at opposite ends of the spectrum too. These lines have the same slope, but different y-intercepts. What kind of lines are those? What kind of lines have the same slope? They go in the same direction but never touch. Parallel. These are parallel lines. Because I can draw my axes again. Let's make it blue. Okay. So at plus 5.
It's really not under her control.
What? And obviously we go up 6, I'm off the grid, right? So I'm going to go backwards. 1, 2, 3, 4, 5, 6, and go 1 over here. So roughly, this is what our line looks like. Roughly. Okay. Now that other line is very similar to what we did on the previous page, right? Same line. This guy, the red one. Because this was also 6x minus 15. So I'm just going to copy this. And we're at 3, 3, 3. Okay. So again, because we've already done that work. So at 3, 3. And then we're going to paste this guy in place. Come on, paste. Give me paste my red line. There we go. Now, you can clearly see that that's pretty much a parallel line, right? Because these lines are going the same direction. Up 6 and over 1 the whole way. They're never ever going to touch. Plus, this tells us that they're never ever going to touch because they have the same slope, different y-intercepts. When they have the same slope, the lines are never going to touch. They can't. We have to have different slopes for lines to intersect. If the lines are going the same direction, they're never ever ever going to touch. Okay, so that was that scenario. So we've had a 1 solution and we've had a no solution. What do you think the last one's going to be? Infinite. Okay. All right, so in number 3, we got, when I take y1 and distribute it, y1's been the same all the way through, 6x minus 15. So on y sub 2, when I distribute, and I get 6x minus 2 minus 13, when I combine like terms, I get 6x minus 15. Okay, so something's going to happen when I set these two equal to each other. Number 1, they're the same equation. So when I move the 6x over, these all cancel out, leaving me negative 15 equals negative 15. That's what we call an identity. The left side equals the right side. That means there's going to be infinite number of solutions. Because they're the same line. These lines have the same slope, right? Which we said in the previous problem are parallel, right? But they also have the same y-intercept at negative 15. Okay? So let's say if I were to graph these by 5s, okay? We're going to make this graph a little easier for us because of this, the way this cockamamie book here wrote it. Let's get rid of this. So here's my y-axis. Okay. And then here's my x. And then we're just going to make this easier. We're going to go by 5s here. So this is negative 5. That's negative 10. That's negative 15. And this is 5, 10, 15. And over here we got 5, 10, 15, and negative 5. Okay. So if I'm down here at 0, negative 15, okay, and I go up 6 and over 1, so my 1 line is going to be like here. So if I make my red line, We'll make this a little skinnier here. So here's my, excuse me. Okay. Okay, so there is our first graph. So let's say I want to take my, I don't think it worked. Clone, there we go. All right, so this line is going to be my other line. We'll make this one like a light green, okay? So if I want to take my y2, which is my same one, if I put this over 15, I'm going to have the same slope. It goes directly over the other one. See how that works? So that means for every solution that worked in y1, the same number of solutions are going to work in y2, which is all of them. And since these lines go on infinitely, that's why there is an infinite number of solutions. So that's the third scenario. So you saw the one solution, you saw the no solutions, and now this is a scenario where there are infinite amount of solutions because y2 and y1 were the same. So we hope you found this tutorial helpful. We're going to stop this and